Yeah, they're right over there.
Yeah. Okay, so we're going to start with a recap for the graphing, just because I know graphing is hard. There are a lot of different details, and so it's hard to kind of keep them all together. And so we're going to go through what you get from each piece. I'm going to kind of show you again my style of doing it. I have a tendency to like to have sort of a summary column of information here that includes points, equations for asymptotes, all that's, max, min, increasing, decreasing, because that way I can just kind of look at my summary and start piecing it all together. We're also, just like we're going to start the work with f of x, we're going to start the graphing with the f of x information, and then we move to what we get from the derivative and what we get from the second derivative. Okay, so this is the one we're going to start with. Anytime you're presented with something that's already factored, do not multiply it out. Because remember, or at least not for finding, let me back up. What information can we get from f of x? A lot. So we start with domain. What else can we get?
Y-intercept.
Y-intercept, those are the first two, probably in that order. And then what? X-intercepts. And then any vertical or horizontal asymptotes, which clearly for a polynomial we will not have any. Okay. So everyone recognizes this is a polynomial, it's just multiplied, it's just factored already. So the domain for a polynomial is always all ribs. Y-intercept is always really easy to find because we just put in x equals 0. So we get -1 times 1, -1. So remember, I think it's best to write it as an xy pair, because then when you go to plot it, it's easier to, that information is more quickly plotted than to write something like f of 0 equals -1. That means the same thing, but this is a much easier point to associate with the graph. So I recommend that. Okay, x-intercepts. So
well,
for
I'm
x,
sorry, how did you get -1?
when I put in x equals 0, 0 minus 1 is -1, times 0 plus 1 is +1.
And then the -1 and the positive one would
They're
cancel, right?
they're multiplied.
Oh, yeah.
Yeah. Okay. Okay. So that's how I get y-intercept. How do we get x-intercepts? You set this equal to 0. So that's why we leave it in factored form to start with. So if you want to, just go ahead and we'll just kind of pull these out this way. Or I could finish factoring. Let's do that. Let's finish factoring first. Does this one factor further? X squared minus 1. Yes. So we see that as a difference of squares. So x plus 1, x minus 1. Does x squared plus 1 factor? No. There are a couple of different ways you can look at this. And I put this in the Unit 3 clarifications, the different ways I'm going to show you right now. The first one is to just try it and see what happens. You get x squared equals -1. Do any real numbers satisfy that? No. So it doesn't factor. Or you can think of it graphically. What does x squared plus 1 look like? What is this shape?
Parabola.
It's a parabola, and it's shifted.
It doesn't cut the x.
Right, it's shifted up. So if I were to graph this thing, it looks like that. Does it ever go through the x-axis? No. So that's another way. That's method number 2. Method number 3 is, I'll get that. Method number 3 is the b squared minus 4ac. So remember, you can always use quadratic formula. B squared minus 4ac is what's the inside of the square root. So check that out first. B squared minus 4ac. What is b in this one? It's the coefficient on the x. Is there 1? No, so b is 0. Minus 4 times a is 1. C is 1. -4. That means you're going to be time. Oh, if you guys could put all the assignments over there. I'm trying to separate them out. Thank you. So -4. So if you were to use quadratic formula, you would be trying to take the square root of a negative number. Can't do that. So there are 3 different ways to know if something factors. Any one of those, you don't have to do them all, just pick one. Okay, so that means that we know that this doesn't factor any farther. So what do we know our x-intercepts are then? This one gives us -1. This one gives us +1, and this one gives us nothing. So we'll write them over here. 1, 0. -1, 0. Okay, have we milked f of x for everything we can get? I think that's everything. So if you want to, go ahead and you can kind of label your information. All right, so the next thing we need to look for is f prime. What are we looking for there? What can we get from the first derivative? What's that?
Like the critical points or whatever? The
Yes.
x-intercept?
Not x-intercept. Increasing and decreasing. Because remember, f prime is instantaneous rate of change, so it's slope. So f prime tells us everything about the function going up and down, up and down. So we know increasing, decreasing, and then max and min, local max and min. That's important, local, not absolute. Okay, so we need to come over here and get the first derivative. We have two choices. We can multiply this out, or we can do product rule. Which one do you guys want to do? You want to review product rule? I actually think multiplying out will be faster, but let's review product rule just for review. Okay, so f prime. How do I know this is a product rule? X squared minus 1 quantity times. As soon as you see the word times in your head, you know you're in product rule. Okay, so first times the derivative of the second, 2x. Plus the second, you guys should be writing this down, not looking at me, because this is something that you guys should already already know how to do. Okay, so now why do we have to multiply out here? Because we see some like terms floating around in here. In order to combine them, you've got to multiply everything out and then set it all equal to 0. So I'll get 2x squared minus 2x plus 2x squared plus 2x, is that right?
2x cubed.
Thank you.
Yeah, I
Yes.
was about to say, it's 2x cubed.
Is that right?
Yeah.
Yes. And so altogether we get 4x cubed. Which if we had multiplied this one out, we would have gotten x to the 4th minus 1 because it's a difference of squares. Derivative of x to the 4th is this. Okay, so now what do we do here? We've gotten our first, this is our first derivative. So now we set it equal to 0. Where is this equal to 0?
At 0.
At 0. This is not a none. Some people are, so let me just, as an aside, if I have 4x times x minus 2, this is a completely separate problem, totally different, not connected. If I set these equal to 0, then this one gives me x equals 0, and this one gives me x equals 2. If I have this, 4 times x minus 2 equals 0, I can write 4 equals 0, and x minus 2 equals 0. This one gives me an answer. What does this one give me? Nothing. So anytime you have a variable, you're going to get some sort of value. A constant doesn't give you any, it's never equal to 0. So even if you break them apart, if you need to write out all the separate pieces, and you'll see that. Okay, so let's come back to this. So 0, so we're going to do a sign chart. This one has no endpoints. If you have particularly business applications where you know your model is only good within a certain domain, then you need to go ahead and put those endpoints on. All right, so I'm going to pick -1 and 1. That seems good for me. If I put in -1, -1 cubed is negative. If I put in +1 cubed, positive. So what do I know? If you like to, if you've left space, I like little arrows, because really, first derivative is about the ups and the downs. It's about rising and falling. So now I can clearly see what I expect this graph, the rough thing to do. And it also helps me visually see when I have increasing, decreasing, and then clearly this is a min, because it went down and then back up. Is there a max?
No.
No. Okay, so increasing would be from 0 to infinity, decreasing, -infinity to 0, max none, min at 0.
0. You have to plug the 0 back in.
But we already did that, actually.
Oh.
But yes, you do. You have to plug it back in. And so this is an important piece also. This is an x-y pair. Where do you get the y value from?
The original.
The original function. Okay, so that's an important piece. All right, so last piece, let's see if I can squeeze this in. Second derivative. The great thing about polynomials is that they can start out with a reasonably high degree, but by the time you get to the second derivative, you're usually down to something small. So here I'll get 12x squared. Set that equal to 0. I still have the same 0 for my sign chart. So if I pick a number over here, say -1, I'll get -1 squared is
Let's be positive.
positive. Everyone agree with that? In fact, this thing is always, I can look at this is always greater than or equal to 0. because it's a square thing. So it's concave up. I don't know if we include the 0. I think we do not, because temporarily it's got no concavity right at that point. So I think when we write concavity here, so we're looking at concave up. So let's finish this. So from the second derivative, what do we get? Second derivative, so first derivative is, original function is about points. First derivative is about the ups and downs. And second derivative is about the curvature. So here I can find concave up, concave down, and what do we call the point in the middle?
Inflection.
Inflection. I hope you don't mind all my abbreviations. It just seems like you know what I'm talking about. So. Okay, so here I have concave up, and I'm going to write that this way, negative infinity to 0. Remember, if you have two pieces, you need to use this union sign, which means essentially together with the rest of it. Concave up, no concave down, and no inflection point. Okay, so have we gotten all the information we can possibly get? Yes?
How do we know that 0 is at an inflection point?
Because it doesn't switch from 1.
Okay.
It's a possibility, but in this case it doesn't. Okay, so now we're ready to put everything on. So the first thing we do, just like we did these, got this information in order, now we're going to put them on the graph in order. So the first thing we'll do is put in all of our intercepts. So I think that's right. Now we need to look at increasing, decreasing. It's decreasing this way, and then increasing. I like the dotted lines because it gives me kind of a rough idea, but it's not the final, it's not all the final answer. Now I need to figure, so is there anything else that goes on? I have the min, that's already there. So really that's, when you're looking to plot points, you should plot all the points you see. So not just these, but really you need to find all your points and plot all of them. So if this were at a different place, go ahead and plot that too. Now let's put in the curvature. It's pretty much always concave up. All your information needs to work together. And so you will know you've made a mistake if you try and graph something. Like let's say for some reason you accidentally got that this was negative. And so you know there's a min here, but now it wouldn't make any sense for a polynomial. So you know, you're going to know if you've made a mistake somewhere because the information won't work together, and it should. All of it works together. So one last thing, let's look at absolute max and min. These are all locals because it's just all right what happens just kind of on either side. Absolute max and min is you have to look at the entirety of the graph, the entire domain that you're working with. So if I look at the entirety of this graph, do I see an absolute max?
No.
No, because infinity doesn't count. So infinity, because absolute max is a concrete number, so infinity is not. So infinity does not count. So no absolute max. Do I see an absolute min?
Mm-hmm.
Yes, so absolute min is where?
-1 or 0.
0, -1. Yep. Okay. So is that okay? We're going to do more graphing, but this was kind of just a review one on polynomials.